A very good morning to Puan Zarina binti Muhammad Ali. We are students from BFC 21103 Hydraulics, Section 3, Group 9. Uh, First of all, I'd like to introduce myself and my group members. My name is Theebashini anak perempuan Rajeswaran, Majlis number CF220211. Rishan anak lelaki Ilham Murugan CF22024A. Sarvin anak lelaki SANGKAR CF220167. Muhammad Ikhwan HAZIQ bin JOUHARI CF220100. Muhammad ZAKARIA bin SUPIAN AF220014. In this presentation, we will be presenting introduction, methodology, result and analysis, discussion, lastly conclusion.
Hi, my name is Muhammad Ikwan Haziq. I will explain about introduction for this project purpose. So, for the Urban Stormwater Management Manual for the Malaysia, or as we call MSMA, changed by the stormwater managed landscape in country. However, with the increased need to meet demand for the green technology and risk of climate change, stormwater engineering face a stiffer challenge in producing an efficient and sustainable urban drainage system, and the integrated stormwater management concept was fully adopted in formulating stormwater drainage master plan for the township development and complying with MSMA. Taman University Paritraja Batu Pahat, Johor is planned to become a showpiece of the region new concept of urban stormwater management, emphasis in a necessary of using MSMA in all stormwater system design and implementation to protect this environment of surrounding area. For the area of catchment, we are using Google Earth Pro. From the value we obtain, for the length of main road is 436 meter long. For the depth is 0.2 meter. And the width of the channel is 1.9 meter with average of 0.3 meter slope. So for the objective for this project is firstly, propose an appropriate drainage system that could effectively reduce this excessive flow. Second, determine the optimal drainage system, design and capacity for the Taman University Padat Raja. And third, analyze the water flow through a proposed channel along the Taman University Padat Raja drainage. Second, for the problem statement, the drainage system was unfit design to prevent flooding and excessive rainfall from causing the overflow on the roadway. And second, when design a runoff drainage system, the capacity of the flow channel is unfit for the area and must be precise analyzed. Thank you.
Hi, I'm Sharvi Shankar. My metric number is CF220167. So today I want to explain about designing size for drain system. Um, we have we are designed for our drain. So we have the length, height, and depth. We have changed to ensure the total volume of water can be um, flow in a right path. So as we see, the diagram shows the designing of our new train, 7 meters, 4 and 5, which in length, breadth, height. So the right hand side, the calculation for the uh, design for the drain has shown. This is the remaining calculation for the uh, drain, and as you can see, the IA value is 463.341 millimeter per hour, and then the CC is 0.95, and then the QQ is 13.2 ms. And I want to explain about discussion. Okay, as we see the comparison between old and new design drainage size. Okay, the old design, the length depth is 5 and 2. So the new design I've increased about 7 and 4. I've increased 2 in both. So when we increased, the hydraulic mean radius will be changed from 2.1174 to 2.5909. Then the flow rate of the drainage also will be changed to from 12 to 956 to 13.705. As we did the calculation above, we found that the flow design of the discharge was found to be higher than flow peak of the discharge. This is for the old design, which means that the proposed new design of the channel section is passed. Not only that, we found that the flow rate of each drainage is different in terms of length and channel and depth, as shown in table 2.7.
My name is Theebashini anak perempuan Rajeswaran, matrix number CF220211. I'll be explaining the methodology. So we must collect the firstly meaning roughness, and we must collect the data from the table in order to begin the calculation. Our group members presumed that the region was a grass channel with short grass cover lower than 150 millimeters. So the meaning roughness is 0.035. Next, dimension and area of the drainage. So the channel section was trapezoidal, then the area, top width, and also vector perimeter was calculated. Based on this information, the R of the trapezoidal drainage was determined to be 0.197 meters. Moving to empirical IDF curves, so the required data was gathered nearby in Johor and the station near store GPS Batu Pahat. Through the area information, we can get the constant value of the area, which is lambda is 64.099, K is 0.174, theta is 0.201, and no is 0.826. One more information obtained was about the area. The business type was commercial, and the minimum the minimum year ARI was 100 years. After the data of the area was collected, the equation below was utilized to get the empirical IDF curves. The empirical IDF curves were 228.573 millimeter per hour. Moving to next, Q rational. So by using all the information, peak flow can be calculated using the rational equation. The peak flow is 0.508 meter cube per second. Next, for Q capacity, the most common empirical method for determining the capacity of the drainage is the Manning formula. So the suggested gradient and the web parameter are used to calculate the potential. The design's peak flow is 0.553 meter cube per second. Next will be the comparison between Q rational and also Q capacity. So the Q assumption for the new drainage design needs to be found following the rational method's final step. The Q assumption was calculated using the Manning equation. Before applying the Manning equation, the area, the perimeter, and also the slope were determined. Then we continued to ascertain the Q assumption, and the design peak flow, which was 0.553 meter cube per second, was significantly larger than the assumption's peak flow, which was 0.508 meter cube per second. And the rational discharge of value must be smaller than the discharge value power. So if the discharge value is lower, you will be perceived a region for the constructed power drain. In this case, the value is greater, so the channel region should move to a bigger region than before until the fair discharge is lower than the discharge capacity value.
Hello, everyone. To answer question one, State the name of stormwater drainage design manual required to be used. Authority for drainage design in Malaysia. So in Malaysia, we use MASMA, which is known as Manual Saluran Monster Alam. It's the stormwater drainage design manual that must be followed as the authority for the drainage design. The acronym for MASMA is Manual Saluran Monster Alam, which stands for Urban Stormwater Management Manual in Malay, has gained widespread acceptance and has subsequently been registered as a training in Malaysia. It's either private or government. Both sectors will be using this manual to drainage system in Malaysia. As for the second question, to identify and justify the reason why flash flood occurs at the location, it has been established that the main reason for flash flood and road strike rain at Taman University Parade Raja is the excessive or loud development discharge. When compared to the peak flow produced from the calculation using the rational technique, the peak flow obtained from the drainage flow rate calculation using Manning equation is lower. The larger volume of rational discharge would arise from the combination of surface runoff discharge and dry weather flow, resulting in flooding, and also underdevelopment of the drainage system, such as you can see in the photo, where there's no drainage and they are just use the natural slope. Therefore, the excessive water flow uh, with the drainage is not effective. They cause flash flood.
So for the conclusion, the civil engineering project often require hydrological studies to ensure successful infrastructure for water resources and minimizing environmental effects. The proposed road through Taman University, Pariraja, drainage offer advantage such as improving water quality, minimizing water collection, improving drainage capacity, and preventing flooding. A thorough analysis of the region's furthest and integrated strategy is necessary for creating the best drainage system. The efficiency of the system depends on careful sizing, capacity design, redundancy, and resilient measure. Retention pond, grid infrastructure, enhanced channel capacity, stormwater diversion structure, routine maintenance, and community outreach are essential components of an adequate drainage system. Addressing environmental issues and setting up a thorough maintenance and management strategy is crucial for long-term viability. The hydrologic and hydraulic analysis is crucial in this project as flooding is a common issue during the monsoon season. The study for the study of meaning roughness, friction, slope, intensity, duration, frequency, land usage types, and average recurrency interval (ARI) is essential for calculating the drainage peaks, discharge, and suggesting the optimal design for one site drainage. Thank you.